All right. Again, like I said, we're skipping to chapter 3, and we are going to skip chapter 2. Today's the 26th. 26th. All right, so parallel lines and transversals. We've actually talked about parallel lines before in chapter 1, didn't we? Remember we said two lines are parallel if what? If they lie in the same plane and they do not do what? Intersect each other. Okay, so we've talked about the definition of parallel lines. That's going to come up a lot through the rest of the book. We're going to say, hey, remember in chapter 1 we talked about the definition of this certain thing? Well, now we're going to do a lot more with it, all right? In fact, a lot of this, the whole entire chapter is called parallel and perpendicular lines. We even talked about perpendicular in here, didn't we? Okay, just briefly, I believe. But we did talk about that. But much of this chapter has to do with parallel lines. You're like, how in the world can you have a whole entire chapter just on parallel lines? Well, just wait and see. All right, there's a lot of stuff to learn about parallel lines. All right, so let's just draw a little example of parallel lines first. So we've got a line right here, we've got a line right here, and it does say parallel lines, so what should you have on the end of these? You should have arrows because they are what? They're lines, exactly. Okay, so those are two parallel lines. Let's give them names. Right now, you could put two capital letters, right? You could put a couple points on the line itself and name it with capital letters. You could do that. But what's a really simple, easy way to name a line? You remember that? A lowercase letter, okay? So we'll just call this L and M. Is that all right? So that's lowercase l, lowercase m. So we got lines L and M. So we say that they would be parallel. Well, there's a little symbol that they use sometimes. I'm going to do this in a different color so it doesn't get mixed up. This is not really an arrow like the arrows here. These arrows indicate that it keeps on going in both directions. Oops, forgot to mic up. There, that should sound a lot better. Okay, these two arrows right here, these arrows right here indicate that it keeps on going in both directions. What I'm going to do is I'm going to put a little, it's kind of like an arrow right inside here, okay? Now I'm going to put another one right there. Do you remember when we had sides? Remember we did polygons and you had sides that are equal to each other? How did we indicate that they were equal to each other? What did we use? Like on the picture itself. Alex, what do you think? Kiki, help you out. Yeah, what do we call them? We call them little, starts with a T. Tick marks, right. Put little tick marks on there. This is kind of, it's not exactly, but it's kind of like a little tick mark. What this is just a little indication that these two lines are parallel to each other. So when you put this little arrow thing in the middle of it, okay, it doesn't have to be dead in the middle. It could be here, but usually we put it somewhere in the middle, I guess. That just indicates that those two lines are parallel to each other. So if I didn't tell you that they're parallel, if all I did was do this right there, they sure look like they're parallel, don't they? But we can't say that they're parallel until they tell us, right? If they told us up here that line L was parallel to line M, then you could say they're parallel, all right? Exactly. You don't know they're equal to each other until they tell you that they're equal. Kind of like a right angle. Remember we did that? You don't know it's a right angle until that little what? That little box, that little square right in the corner there, okay? So you can't just look at it and just assume that they're parallel to each other because you don't know that, all right, until they tell you. But if they do this and they do this, then that tells you that they're parallel, okay? They're not always going to put in different colors. I just did that so it stands out a little bit. You could also do this. You could put two little arrows. But now, if that has one or two arrows, this has one, that means that they're not parallel. But if they both have two, that means they're parallel as well. Because you could have other lines. We're going to do this pretty soon. You're going to have other lines crossing these parallel lines that could be parallel as well, all right? So like this might have two arrows, and then a line comes like this, and a line comes like this. You would just have the one arrow for the ones that are parallel. Does that make sense? Okay, so anything with one arrow, that means they're parallel, or two arrows, or you can go 3, 4, 5. It doesn't matter, but usually we don't have that many. All right. Because, like I just said, if you had two sets of lines, if you had a line come in here and a line come in here, right? So you might, and they might be parallel to each other, but they're not parallel to these ones right here. Then you put 2 for one and then just 1 for the others, okay, just to indicate. Yeah, it's the same concept, right? If you had two angles equal to each other, you could have like one arc and one arc, Or, excuse me, another set of angles might have 2 arcs and 2 arcs. Just means the ones with 2 are equal to each other. The ones with 1 are equal to each other. Same thing with this. The ones with 1 arrow are parallel. The ones with 2 arrows are parallel. Yes? Yeah. All right? You with me on that? So, let's do this. Let's put another, I'll tell you what, let's do a different color. We'll go bright yellow. What if I had a line that crossed those 2 parallel lines? We give that a name. We haven't talked about that this year, okay? So these 2, well, they're parallel, so I'm going to put a little arrow thing, okay? This line that crosses them, we give that a special name, and we call that a transversal. Transversal. We're going to talk about that a lot. And in fact, today, we're going to use this transversal quite a bit. It's going to be really, really important, okay? Now, the lines don't have to be parallel to have a transversal. For instance, I could have a line like this and a line like this, and then a line that goes through them. Oops. Let's see what I want to do. There we go. Okay, so you got these 2 lines, and this one crosses it. So the line that crosses 2 lines is called a transversal. Everybody see that? Now, obviously, these 2 lines right here aren't parallel, so you don't have to have parallel lines to have a transversal. It's just any line that crosses 2 other lines would be considered a transversal. Make sense? All right. Let's do this. Yeah, we'll do it that way. So let me draw 2 other lines. They're not necessarily going to be parallel to each other, so I'll make them so that they don't look parallel. Now, these are lines. I'm just not going to take the time to put arrows on the end of it. Are you okay with that? All right, so we'll still call them lines. Just pretend there's arrows on the end. I'm just not going to put the arrows on here. And I'm going to draw a transversal. Okay, so I got 2 lines. We say this. We say that there's 2 lines cut by a transversal. We use that word cut. It means it intersects those 2 lines. It intersects right here, and it intersects right here. So that transversal is very, very important. You know what? I am not going to do what the book does. I'm going to do it like this. I'm going to draw 2 parallel lines. Okay? Yeah, and I'm still going to do a transversal. Sorry if you wrote that in your notes, but I'm going to go ahead and just draw 2 lines that look parallel. Now, if I didn't tell you that those 2 lines are parallel to each other, could you say that they were parallel? You could? If I didn't tell you? No. Okay, I cannot just assume that this line right here and this line right here are parallel to each other. All right? Because I didn't tell you. This could be off half a degree from this one, right? And you wouldn't be able to just look at it and tell. Now, I'll tell you right now, I hit the shift key when I did it, when I drew those lines, and that means they're exactly, parallel to each other. But you can't assume, all right? Everybody hear me? You cannot assume that these 2 lines are parallel to each other unless they tell you. If they said that line A and B are parallel, then you can say they're parallel, all right? If they put the little arrow here and here, then you can say they're parallel. But if they don't give you any of that information, you cannot assume that they're parallel. Question? Probably not. But we're going to show that they're parallel. I wouldn't say prove necessarily, but we're going to be able to show that these 2 lines are parallel if we know some other information, all right? But that's a little bit ahead of us.
Question asks, is this line parallel? I'm just supposed to say no because it could be like...
If they don't give you any numbers for these angles, and if they don't tell you that this line and this line are parallel, okay, and they don't tell you, like up here, line L is parallel to M or whatever, if they don't tell you, you cannot make an assumption that they're parallel to each other, even though they look like it.
So you would say undetermined.
Yeah, we're not going to say, just hang on. They're good questions. They really are. I'm glad that you're looking to the future, but we're going to answer those questions here in a few minutes, okay? All right, so let's do this. Let's just name some angles. I'm going to put some angle numbers up here. Remember, we can name angles with numbers. I think it's a lot easier for what we're going to do right now just to name them by numbers. So I'm going to say, oh, I thought I changed it to red. There we go. Now it should be red. All right, so there's angle 1, 2, 3, 4. Do you see those angles right there? Now, down here, you got some angles as well, don't you? All right, so 1, 2, 3, 4. What do you think I'm going to call this one? 5. How about 5, 6, 7, 8. You could call it 6 if you wanted to. It doesn't have to go in order like that, okay? You could use any numbers that you wanted to. But we're just going to make it real nice and easy. So you got 8 angles here. Now you have other angles as well, all right? You've got like this whole big angle right here, and you got this whole angle. But these are the angles we're going to deal with just right now, okay? So let's take a look. We have some names for some of these angles. I want you to look. Let me see what they do. They don't tell you this in the book. Probably in another section they will. Let me see. No, they don't tell you this. But I'm going to tell you this anyway. Look at angle 1 and 4. Do you see how they're opposite each other like this? Okay. See this angle right here and this one? What other angles are kind of like opposite each other? 2 and 3. Okay. What about down here? 5 and 8 and 6 and 7. Okay. We have a name for that. This is not in the book. I'm sure that they're going to touch on this in a later section or chapter. But I just decided, let's just talk about it right now. So we call those, we don't call them opposite angles, we call them vertical angles. Okay? Vertical angles. Right? That's a symbol for angle right there. Remember that one? Yeah. So let's list the vertical angles. So angle 1 and angle what? 4. Okay? And angle 2 is a vertical angle with what? Angle 3. What about down here? Angle 5 and angle what? 8. And then angle 6 and angle what? 6 and 7. See how they're across from each other right here? Okay? They're opposite each other. They're across. 5 and 8. 5 and 8 are across from each other, right? 6 and 7. Everybody see it? 2 and 3, 1 and 4. They're some of the easiest angles to look at and determine that they're vertical angles, okay? And I'll tell you what, I'll tell you this as well. I probably shouldn't, but I'm going to. The vertical angles, anytime you have two lines that intersect, anytime you have two lines that intersect each other, you're going to have two pairs of vertical angles. And those vertical angles are always, let me get my pen working here, are always equal to each other. Or sometimes in geometry, a lot of times we say congruent. All right? I'm not going to be crazy picky if you say congruent or equal. Some teachers are. Some teachers say, no, that's not right. They're not equal. They're congruent. All right? And I understand what they're saying. But vertical angles are equal to each other. So if angle 1 was 120 degrees, what would angle 4 be equal to? 120 degrees. Okay? If angle 2 was, let's do this. What if angle 1 was 120? What would angle 2 be equal to? You should be able to figure that out.
60.
It would be 60 because, look,
180 minus 120.
That's right, because that whole thing is 180, correct? If I told you this was 120, you go 180 minus 120, which is 60, all right? Let's do that. Let's use these particular angles right here, and we can actually solve, just knowing one of the angles, I can tell you what every one of these, 1 through 8, are equal to. Okay, isn't that cool? Because watch. Well, actually, we're going to have to learn something before you say something down here, okay? But watch. If this is 120, this is 60. What can I say about angle 3? Angle 3 is 60. Why? Because they're vertical angles. Now, you know what you just did right there? Without even knowing, you actually did a little bit. What you just did right there, you did just a small portion of a proof. You just proved, okay, that you said that angle 3 was also equal to 60, and you gave a reason to back it up. That's what proofs are basically, what they basically are, okay? Give a statement and back it up with a reason. Why is angle 3 equal to 60 degrees? Because it's vertical angle with angle 2. I know angle 2 is 60 degrees. You with me on that? So that's a very, very small portion of what a proof is all about. Tell me something about angle 4 then. Yeah, that's also 120 because look, they're vertical angles to each other. Vertical angles are equal to each other, okay? You with me on that? Now, there's something else. In order to find these down here, there's something else we have to learn, all right? And we are going to learn that in just a minute here. So let me get rid of some of this stuff. Actually, I don't want to get rid of the 2. Let's keep the 2 in there. Let's get rid of all the other junk that we wrote. It's not really junk, but You get the idea? Let's get rid of this. Let's get rid of this. All right, so we start with this clean slate right here. Now, there's some other types of angles that we're going to learn, okay? Let's do this in yellow, all right? Let's see. Let's just go with the first one they do, corresponding. Yep. Now, watch this. Look at angle 2. Do you see how there's a clump of 4 angles up here at the top? And there's a clump of 4 angles down here at the bottom, okay? What do you think might be true? Look, we didn't change the angle of that transversal, did we? Right? It's just a straight line through here. Let's just say this. This is the top right angle in this clump of 4 up here. Do you agree? Okay. What's the top right angle over here? It's 6, okay? We call those, listen, this is very important, we call those corresponding angles, okay? Let's write that down. Okay, you don't have to make silly comments every time I say something. All right, there's no reason for it. Just listen. So we call these corresponding angles. Okay, so 2 and 6 would be corresponding. Let's go through the rest of them. 1 and what? 5, 3 and 7, 4 and 8. Do you see how they all match up with each other? They correspond to each other, all right? They're in the same spot, aren't they? Angle 2 is in the top right, 6 is in the top right, so they're corresponding angles. 1 is in the top left, 5 is in the top left. 3 is the top or the bottom left, 7 is the bottom left. You get the idea, right? Now, we have a thing, it's on page 109, and it's called a postulate because we just accept this as fact, all right? Remember, a postulate, you just accept this fact. You can't really prove it. So we have a postulate that says that the corresponding, when you have, actually, let's do this. Now let's say that these are parallel to each other, okay? If these two lines are parallel to each other and you have a transversal, then the corresponding angles are equal to each other, okay? So if I was to write this out, I would say if you have parallel lines, then I should say this. I'm not going to write it all out. But if you have parallel lines cut by transversal, do we have that situation here? Yeah, I said these lines are parallel, but there's little arrows there. If you have 2 lines cut by transversal, then the what? The corresponding angles are going to be equal to each other. That's a shorthand way of writing it. If you have parallel lines cut by transversal, Sam? If parallel lines are cut by transversal, then the corresponding angles are going to be equal to each other. So I can say now that 2 and 6, yeah, they're corresponding angles, but what can I say about 2 and 6? I could say that angle 2 is what? Equal to angle 6. And let's just go through the rest. I could say that angle 1 is equal to angle 5. I could say that angle 3 is equal to angle 7. And I could say angle 4 is equal to angle 8. So that's a lot of stuff that we know. Now, remember we said if this was 120, this is 60, this is 120, this is 60. Now, knowing that corresponding angles are equal to each other, now we could say that 2 and 6 are the same. So if 2 was 60 degrees, what is angle 6 equal to? 60 degrees. Then what's angle 7? 60 degrees. What's angle 5? 120. Now, what's angle 8? It's 120. Do you see that? So just knowing one of the angles, just one of them, with what we've learned so far as vertical angles and corresponding angles, I could tell you what all 4 of these angles are equal to. And that's kind of the stuff you could see. This could be a homework question, right? Or a quiz or a test question, all right? They'll give you one of the angles. They'll give you angle 1, and they're going to ask you to solve for angle 7. So if angle 1 was 120 degrees, what do you think angle 7 is going to be? It's going to be 60 degrees. Do you see that? Okay. Well, you would say that 1 and 5 are equal because they're corresponding. And then 5 and 7, we have a word, we haven't used it yet, but we have a word when 2 angles add up to 180, we call them supplementary angles. Have you ever heard that? Maybe in middle school they talked about complementary, supplementary. I don't know if they do that or not. But in geometry, we'll definitely get to that. We'll get to that I don't know if they do that in here or not. Probably not. All right. So let's move on. Let's get rid of my yellow. I'll keep the corresponding angle thing up there, but let's just get rid of this circle and get rid of this circle. Let's go to a different color. Let's go to blue, and we got something else. Now, this is a really important one. What I want you to see is this. Look at 3 and look at 6. You see that? Now, we have a name for that, but look at 3 and 6. Again, go by the 120 and 60 thing. If you knew what angle 3 was, we're going to say it's 60 degrees, okay? What do you think angle 6 is going to be? 60 degrees. Again, because why? Because angle 3 is 60. That means angle 7 is 60 because they're corresponding angles, right? And 7 and 6 are equal to each other because they're what? Vertical angles. So 3 and 6 must be equal. Everybody see that? You basically just did a proof right there, okay? Gideon, you watching all this? Sam, you watching all this? Somebody tap him, please. Thank you. Shake him then. Don't tap him. Apparently, there you go. Gideon, get your head up or I'm going to write you up. If I see your head down again, okay, you'll get a SLD or whatever you call it, ASD. We used to, do you know what SLD? We used to give SLDs all the time. It's called silent lunch detention. And so you would have to go into some teacher's room during lunch, and then you couldn't talk. You had to just sit there all during lunch by yourself. So that's what we used to give. But now we're giving ASDs, which is a little tougher because you got to miss school. So anyway, so take a look. Look at 3 and 6. 3 and 6 must be equal to each other. Agreed?
Agreed.
Now, they're not corresponding, okay? This 3 is on the left side of the transversal. The 6 is on the right-hand side of the transversal. Everybody see that? And they're also in between the two parallel lines. Look at 3, 4, 5, and 6. We have a name for that as well. We call them the interior angles. We talked about interior... Braden, get your feet off. We talked about interior angles or interior points of an angle. This time we're talking about actual interior angles, but they're in between what? The two parallel lines. So 3, 4, 5, and 6 would be all considered interior angles. What about 1, 2, 7, and 8?
Exterior.
They would be exterior angles, okay? And we have something right now that talks about being on the opposite side of the transversal and being inside or interior angles. We call that alternate. Now, the alternate means it's on different sides of the transversal. 3 is on the left side of the transversal. 6 is on the right side of the transversal. You with me on that? And they're alternate, and they are interior angles. And the alternate also is they're not just like across from each other. This is up here in the top left. This one right down here is in the bottom right of my interior angles. Everybody see that? So we call these alternate. I'm going to shorthand alternate, right? I just put INT, angles. Now, if I said this was 60, I also said that was 60. So guess what's true about alternate interior angles?
They're across from each other.
Well, what did we say about corresponding angles? We said that they were what?
They're equal.
They're equal to each other. So what's true about alternate interior angles? They're equal to each other. So 3 and 6 would be equal. Why? Because they're alternate interior angles. What about, what's another pair of alternate interior angles here? 4 and 5, okay? So 4 and 5 would be equal to each other as well. Now, does that mean 3 and 4 are equal? No. So what am I going to do here? I'm not just going to put one arc. I'm going to put 2 arcs, and then I'm going to put 2 arcs here. Okay, that indicates that 4 and 5 are equal to each other, but they're not equal to 3 and 6. Make sense? All right, so 3 and 6 are equal, 4 and 5 are equal. Let's write that down. So angle 3 is equal to angle 6, and angle 4 is equal to angle 5. And again, what's my reasoning for it? Because alternate interior angles are equal. So if I wanted to write out, now this is actually not a postulate, it's actually a theorem, because we could actually prove it. And we kind of did, because we said 3, let's prove that 3 and 6 are equal. You ready? All right, so this is very informal, but it's basically a proof. So 3 and 7 are equal. Why are 3 and 7 equal? Because they're corresponding angles, right? And we know that corresponding angles are equal. Okay? What about, so watch, let's just write this down. So 3 and 7 are equal. And why? Give me a reason. Corresponding angles are equal. I'll just put that. Corresponding angles equal. Okay? That's my reason. All right? Got to back it up. So now 3 and 7 are equal. Tell me something about 7 and what? And 6 are equal. Why are 7 and 6 equal? No, 7 and 6 aren't corresponding. What are they, Anthony? They're vertical angles. So I write that as my reason. Vertical angles are equal. All right? Vertical angles are equal. So look, 3 equals 7. 7 equals 6. That means that what? 3 must equal what? 6. Now here's a reason you probably haven't heard of. They probably went through this in chapter 2 that we skipped, okay? But we call this, let's see, what do we call this? We call this the transitive property. You might have learned these. Do you remember like associative property, transitive property, commutative property? Do you remember that stuff? Probably in Algebra 1, I think you did that stuff, right, last year? Okay? That's transitive property. So if A equals B and B equals C, then A equals what? C. That's the transitive property. Isn't that what's going on here? Watch. A equals B, B equals C, so A equals C. All right? That's the transitive property. This thing right here is a proof. So somebody said, are we going to prove this? Yes, we are, and we just did. Okay? I'm not going to put this on a test or a quiz. Okay? I'm just showing you. All right? Because we skipped a whole entire chapter talking about proofs. But that's basically what a proof is. It's really not that bad, is it? Alex, you want to keep the mumbling down? Okay, because, yeah. All right, so our theorem basically says this. If two lines are cut by a transversal, and if the alternate interior angles, I'm sorry, I was doing something else. If two lines are cut by a transversal, so basically, I'm sorry again. Oh my gosh, if I could get this right. If two parallel lines, that's important. If two parallel lines are cut by a transversal, so if I have two parallel lines, then what must be true? The alternate interior angles are going to be equal to each other. All right? So this one right here is a postulate. We just accept the corresponding angle thing without proof. You can't really prove it. You just accept it as true. This one we can prove, though. All right? That one right there. So if we can prove it, what do we call that? A theorem. Remember, this is a postulate. This one is a theorem because we can prove it. Wow, I can't believe they do that one first. If you have parallel lines, it's just comma because that's just grammatically correct. If, then, you always put a comma. Okay, so if you have parallel lines cut by a transversal, I left that out, okay, but you really need that in there. So if you have two parallel lines cut by a transversal, then what must be true about them? Then the alternate interior angles must be equal to each other. But you got to have all that. You got to have that situation, all right? You got to have two parallel lines, and you have to have a transversal for this to be true. So let's do a couple more. I'm going to go a little faster since I think you're kind of catching on to what we're doing here. Let's go 1, 2, 3, 4, 5, 6, 7, 8. Same thing. I just had too much stuff around there. So let's do that. Let's do... all right, let's do this. We have another one. We only have 5 minutes, so I think, let me see. Yep, 5 minutes. So here's another one that we're going to do. Now, everybody look at this. These are not going to be equal to each other now, but what did we say about 1 and 2? So angle 1 and angle 2 are not equal to each other, but they do form a straight line, so they must add up to what? 180. Do you remember the word that I gave for that? If two angles add up to, if they add up to 180, okay, that's add up to means, then they are supplementary. Okay, write that down. Did I write that down earlier? Supplementary. Okay? That means they add up to 180. So Angle 1 and angle 2 would be what? Supplementary angles to each other, right? What about 1 and 3? They would be supplementary angles. 1 and 6 would be supplementary. Keep talking. 1 and 7. No. 1 and 5, they're equal to each other. They're not supplementary. 1 and 7, if they add up to 180, then they're going to be supplementary. Okay? Remember we did the 120 and 60 thing? All right. So let me go through some things here. So here's one. So if you have parallel lines, I'm going to start off with this again. If you have parallel lines cut by a transversal, I'm leaving out cut by transversal just because it takes too long for me to write, okay? But you can write it down. If two parallel lines cut by a transversal, then the alternate exterior angles. Now, what does that mean? Alternate exterior angles. Give me an alternate exterior angle with 1.
2 and 7.
Okay, 2 and 7 would be 1. Since I got 1 already marked, what would it be? 1 and what? 8. I'm sorry. Yeah. 1 and 8 would equal each other. Okay, I was going to go supplementary, but I forgot about this one. So the alternate exterior angles would also be what? Equal to each other. Do you see that? Okay, so alternate exterior angles are also equal to each other. Let's do, I'm going to erase this just because I don't have much room, but you can keep it on your notes. Let's do another one. We did alternate interior. Okay, here we go. Consecutive interior angles. What in the world does that mean? Consecutive interior angles. Let's do this in a different color. They're interior angles, so 3, 4, 5, and 6. But which ones are consecutive? It means they're on this. Let me see, what is it? So look at this one right here. Watch. You see this angle 4 and this angle 6? Are they equal to each other? No. 4 is obtuse, 6 is acute. So these, sometimes we call them same side interior. They call them consecutive interior. I used to teach out of a book that calls them same side interior because they're on the same side of the transversal. This book calls them consecutive. So I'll just write this quickly because time is short here. Consecutive interior angles are, they're not equal. What are they? They add up to 180, so they are supplementary. I used to call them same side. The book I used to teach out called them same side interior angles. I like that one better because they're on the same side of the transversal. But consecutive means like this one and this one, okay? And then 3 and 5 would also be supplementary, okay? So 4 and 6, remember, they're not equal to each other. They do what? They add up. So angle 4 plus angle 6 must equal what? 180 degrees because they are supplementary, okay? You have one more. Let me do that real quick. The bell's probably going to ring, but let me do this super quick, okay? So just hang on. So if you have two parallel lines, so we know that these are parallel lines because I put that little thing right here. Now look at this. This is not just any old transversal. What kind of transversal, what kind of angle do you think this makes? Right, so if I told you this, we have a theorem that says this. If it's perpendicular to one of the parallel lines, everybody watching? So if I told you that, okay, if I told you that it was perpendicular to this parallel line, what do you think it's also to the other parallel line? It's also perpendicular to the other parallel line. Here's your homework. You're doing page 111, and you're doing 1 to 21, okay? This is section 3. 1. Remember, we skipped chapter 2. So there it is right there. Sorry, I didn't make you a lesson plan for this week. Hopefully tonight I'll be able to get that done for you, and I'll give it to you. But there it is. There's your homework. Section 3.1, page 111. You're doing 1 to 21.